In this lesson, we are going to learn about a line of best fit and how to draw a scatter plot for data. So you'll see up here I have our classes heights and arm span that we took in chapter 14. And you'll see that you have that chart also. So we're going to make a scatter plot of our data. Now we've learned how to make scatter plots before in advanced algebra, so we're actually going to use our calculator for this one. The one thing I want to point out is Noah was gone on the day we did arm span, so we're excluding him from our data. We don't have an x and a y for him, so we're going to graph height here and arm span here. And I'm going to let us put this data in our calculator and kind of sketch it. Okay, so I actually, just to save time, put this data in my calculator already. So if you go to Stat, Edit, why don't you pause the video right now, and I put all of the heights in L1, which is why I called height my x-axis, and I put all the arm spans in L2. Remember, you're skipping Noah. So go through and do all of that, and then unpause the video. Okay? So now that you're here, to make a scatter plot, I'm going to go second, y equals, and I turned on my stat plot. You might have yours off, so turn that on, hit enter, and then I go down, and this first one actually is the scatter plot, so hit enter on that. Let's say, like hypothetically, let's say I had a histogram. See how that changes? So when I go over to the scatter plot, I hit enter, and it does say X list is L1, Y list is L2, that's good to go. Then I hit zoom 9, and it's going to show me my scatter plot. So I want you to copy this scatter plot onto your graph on your worksheet. We should maybe plot these more professionally, but since we have so many values, I'm going to let you kind of copy this off your calculator. If we had fewer values, I would want you to actually plot each ordered pair separately. So we're going to do a little bit of a sketch since we're going to use our calculator for most of this. So I'm going to use my calculator right now, and I'm going to sketch in these dots. So I don't have like a number range here. I'm not doing anything fancy here. I'm just going to start putting in where I think I see some dots. Hopefully you can tell where I'm looking on my calculator to get these. So my scatter plot looks kind of like this. Now this is definitely a sketch, right? But I can tell by looking at it, I see that it looks like it has a positive correlation. Do you see how it has maybe a positive slope? And so when we're doing the form, the direction, the strength, and the outliers, we're going to be looking at this data to determine that. So I want you to take a look at that. The form, the shape, outliers, you take a look at what you think is happening there. So in that first one, I'm going to talk about the form as either being linear or non-linear. I think our form right here looks linear. When I look at my calculator, it does kind of look like there might be a little bit of a curve at the top of my graph. Let's look at that. See how this kind of seems to have a little bit of a curve? So I think you could maybe discuss it as being nonlinear, but we're trying to do linear data today, so our class maybe happens to have a little bit of a curve, but normally this data is going to be linear, meaning I could draw a straight line through here. So I'm going to describe this form as linear. So we'll say linear. The direction, well, it looks like it's positively correlated because we're going up, right? So I'm going to call the direction positive. Negative would be going this way. So as your height increased, your arm span would be going down. The strength. So take a look at how our dots are going. If it's strong, let's say we were going to draw in a line of best fit. If it's strong data, and I'm just going to sketch one right now. I know this isn't the right one, but let me just sketch something. That's a terrible line. I'd probably move it down, in fact. Well, there we go. That's a little better. So now this line of best fit here, if my values are all kind of close to this line, I would say it has strong correlation. If they're more spread out, I would say it's weaker correlation and maybe no correlation. So my strength right now, I'm going to describe this as rather strong. This is strongly correlated. My dots are pretty close to that line, right? There's not too many. And then if there's any outliers, an outlier would be someone like right here. They're a little shorter, but they have a huge, oh, just kidding, they have no arm span. That makes no sense, does it? How about an outlier like right here? That person is shorter and has a large arm span, or like right here, a taller person that has a very small arm span. Those would be our outliers. We don't have any outliers in our class, so we're actually going to say none. And this is an opinion. I mean, we don't have a way to find this yet, so none. We have no outliers right now that stand out. So it's in my opinion here. Now, to actually find the line of best fit, we're going to find the equation. I drew a line that fits the data. Okay, this is from chapter 5. We find the coordinates, we write the equation, and you use your equation to make a prediction. Now remember, we did this on our calculator, so I would like you to do this on your calculator because that gives us a more accurate answer. So we're going to use our calculator, and right now I have the data in there already for this, don't I? I put those in, so I'm going to go second quit, and now I'm going to go to stat, then I'm going to go over to calculate, and then number 4 is our line of best fit. If you remember doing that earlier in the year. So linreg, I hit enter, and there's my line of best fit for my data. So my slope would be y equals 0.94x plus 8.64. So I'm going to put that in my notes. Let me just do this on my calculator quick because I just lost those numbers. Okay, so 0.94x plus 8.64. And I am rounding to the nearest hundredth. So there's my line of best fit right here. Now you could do this by hand, but remember when we did this as a class, I think it was 2.5 maybe was the section, we said the calculator was a much better estimate. So our slope is almost 1. So for every inch in height, your arm span goes, or centimeter we measured in, didn't we? For every 1 centimeter in height, our arm span went up almost 1. That's pretty, we'd think it's correlated, right? Haven't you heard that your height is the same as your arm span? And then our B value, our starting point was 8 centimeters. So that's kind of at 0, we think it's 8. It's kind of deceiving. The bottom part then asks us to predict the arm span of someone who's 172 centimeters. So to do that, I would plug in that 172 for x. So I'm going to take 172 times 0.94 and then add 8.64, and I would predict that someone who's 172 centimeters would have an arm span of 130.32. Now this is just a prediction for our class. Since this is just our class's data, we wouldn't try to make predictions on other people's data. Maybe our class is weird somehow. We're all really proportional compared to most people, or else we're off. Who knows? So that's how we make predictions. So that's kind of a review from when we did this first try, it was. And if that makes sense, hopefully you kind of remember doing that. If not, make sure you ask me questions tomorrow because you'll be expected to do that. You're going to have a worksheet tomorrow and a couple of objectives, so let me know if you have any questions.